I'd like to show you an example of a Newman projection problem. So your first step is to set up your graph, and on this axis you'll have energy, and on this axis you'll have a degree of rotation. And you'll start out here. I like to start out at 0. There are other diagrams you'll see that will start out at 180 and then go across, but 0 is fine. And then do it by 60s, because that's going to be how you're going to do the rotations as well. Alright, so now we've got that set up. Now we can look at this very first instance. We're looking down the plane of this bond. There's the I there, and here's the C that we're going to be looking at. Now attached to this C we've also got two hydrogens, and those hydrogens aren't being shown, but I'll put them in. And we've got two hydrogens on the one at the back as well. And we're going to start out in the anti in the same situation as we have here. So what that means is that we are going to have the front carbon, which I'm going to put with a dot, and connected to that we have an ethyl group, that's this entire group here, and two hydrogens. So that's the front carbon covered. Now I'll draw a circle, and what's going to happen is these other groups attached to the back carbon will come out from the circle, and that's how we know they're attached to the back, because they come outwards from the circle. So we've got two hydrogens there and a cyclopropyl group coming down here. There we go. So that's our first one, and I'm going to call that one anti. And that's going to be here. And it's important not to start it down here at 0, because it doesn't have 0 energy. It has some kind of energy associated with it. So that's anti right there. Now what we're going to do is we're going to rotate this around 60 degrees. And when I do that, I can either choose to rotate the back or the front, just to be consistent. And it doesn't matter which way you rotate, counterclockwise or clockwise, again, as long as you're consistent. I'm going to choose to rotate the back, and I'm going to rotate it clockwise. Let's get a good circle going here. It's better. Alright, so I'm going to rotate the back, which means I leave the front the same. Now when I rotate the back, I can put the cyclopropyl here, I'll put the hydrogen here, and I'll put the hydrogen here. Now of course these are going to be eclipsed, because if we're going to rotate this 60 degrees, we know that this angle between this one and this one is 120, so the angle between here and here is 60. So this is going to leave everything here eclipsed. Now when we draw an eclipsed form, and I'll call this eclipsed 1, we draw it so that the eclipsed groups are offset at the back from the front ones. So you don't draw them exactly behind, just a little bit offset. And as far as the energy goes, it's going to be obviously higher than the anti, and I'm going to push it up to here. So I'm going to call this one eclipsed 1 or E1. And there's my E1 right there. Now I'm going to take it around another 60 degrees. Again, I leave the front the same. And this form is called gauche. It is another staggered form, just like anti is, but now the ethyl group and the cyclopropyl group are closer together. So we're expecting an energy that's not quite as low as anti, but not as high as any of the eclipsed ones. So we're looking probably in energy about here for the gauche. Okay, now we're going to take it around another 60 degrees. I'll do this one down here a little bit. And again, we leave the front the same. And now we're going to put the cyclopropyl group here, put the hydrogen here, and put the other hydrogen down here. Now this is a very high energy eclipsed form. It's higher than this one because now you've got these two large groups very close together and interacting with each other. So we're going to be thinking this is going to be higher than the first eclipsed even. So we're going to put it up here. And this is now 180 degrees from where we started. And you can see that because we started down here and now it's moved all the way around to up here. So it's moved 180 degrees from where it was. And that's my eclipsed 2, or I'm just going to call that E2. I'll just put it up here. Now as we continue around, we're going to get the gauche again. That will be at that'll be at 240. And then we'll get the eclipsed 1 again, and then we'll move back to anti. Well, that'll be the full circle. Alright, so there you go. That's our energy diagram right there. And I don't have to draw, or at least I don't feel like I have to draw these particular Newman projections because they're really just pretty much the same as the gauche and the eclipsed 1 and the anti again. So that would be the completed diagram right there.